In this video, we'll be looking at how to find limits at infinity. We have a theorem that will be useful. Basically, it says that if you have a constant divided by some power of x, as x approaches infinity, this expression will be equal to 0. Likewise, as x approaches negative infinity, this will be equal to 0. To get a feel for this theorem, let's just look at 1 over x. Now, as x approaches infinity, that would mean that we're going maybe from 1 over 10, and then 1 over 100, and then 1 over 1,000, and 1 over a million. And as our x value gets bigger and bigger, this whole fraction, or the whole value here, approaches 0. Also, if we looked at 1 over x and x was approaching a negative infinity, so that would be 1 over negative 10, 1 over negative 100, 1 over negative 1,000, and so on, or negative 1 million. This expression also approaches 0. So we're going to make use of this theorem to evaluate limits. The first problem that we're going to be doing is we're asked to find the limit as x approaches infinity of this expression, 3x squared divided by x squared plus 1. So our first step is to divide the numerator and denominator by the highest power of x in the denominator. Because we don't want to get a 0 in the denominator. So our highest power of x in the denominator is x squared. Just so happens it's also in the numerator. But our highest power is x squared. So I'm going to divide every term in the top and the bottom by x squared. Then we're going to simplify. So this, the x squareds cancel on this one, and I have just a 3 in the numerator. On this one, the x squared over x squared is 1. And then 1 over x squared is 0 as x approaches infinity. So if we do the math, we get a limit of 3 divided by 1, which is 3. So remember that the whole key is the limit as x approaches infinity. So as x gets bigger and bigger and bigger, this expression approaches 0. And that's the whole key for simplifying this type of problem. Let's do another one. There's not really much to do on this one. We're wanting to find the limit as x approaches infinity of this expression, 5 minus 2 divided by x squared. Now this part of the problem, since there's no x involved in that, it's not affected by this limiting process. So the limit as x approaches infinity of this term is just still going to be 5. minus, and then as x approaches infinity on this term, it becomes 0 as the denominator gets bigger and bigger and bigger. So we have 5 minus 0, and we see then that the limit is 5. Let's try another one. Now this one we'll want to divide the top and the bottom by the highest power of x that's in the denominator. So we want to divide by x on every term. And then simplify. 2x over x, those x's cancel, and this becomes 2. As x approaches infinity, this term approaches 0. On this one, x over x is 1. And then on this one, 1 over x as x approaches infinity approaches 0. So this simplifies to 2 over 1, which is just 2. Right, for this example, we'll want to divide top and bottom by the highest power of x in the denominator. So we'll divide every term by x squared. So this simplifies to, this x cancels with one of these, and I have 2 over x plus 5 over x squared. These x squareds cancel in this term, so I have 3 plus 1 over x squared. Now the limit on this, as x approaches infinity, we have 0 plus 0 over 3 plus 0. So 0 divided by 3 gives me 0. Another example. Again, our highest power of x in the denominator is x squared. So I want to divide every term by x squared. And then if I find the limit on this, this will be 0 minus, x squareds cancel here, so I have 3. And this one, the x squareds cancel, and I have 4. And on this one, the limit as x approaches infinity will be 0. So this simplifies to a negative 3/4. Alright, one more example. In this one, we want to divide by the highest power of x in the denominator. So we're going to divide every term by x squared. So we're finding the limit as x approaches infinity of 2x plus 5 over x squared. And then this simplifies to 3 minus 1 over x squared. Now as x approaches infinity, this term is going to approach infinity. So I have infinity plus 0 over 3 minus 0. So this is infinity over 3, which is infinity, and a finite limit does not exist. So depending upon what you're looking for, you may give the answer, the limit, as infinity, or usually it's a finite limit that you're looking for.